Yeah, thank you for everyone. Thank you to everyone for dialing in from wherever it is you are across the country and overseas, etc. Yeah, look, I really appreciate everyone's time. This is a pretty exciting uh, subsequent, webinar to our previous webinars, and obviously our white papers that we've released as well. So if you haven't got access to the white paper, Nina's going to drop that link into the chat function. So feel free to use the chat, use the Q&A facility as well if you've got any questions as we progress as well. So again, look, just wanted to recap in terms of what it is we do. For those of you who aren't familiar with instant analytics, we've been around for a little while now and work across the high hazard industry sector and very much specialize in learning from serious incidents and also the effectiveness of controls in the workplace. We're surrounded by a bunch of very passionate people, including Warren Smith, who's on the call or the webinar today, and also our advisory board, of which Anthony also is at the helm of that as well. So in terms of the work we actually do, we do a whole bunch of work in this space, and some of our tools and approaches and methodologies are used for either validating metrics. We quite often get involved in looking at the classification of serious incidents from a governance perspective, but then also look at analysing controls to really better understand how effective controls are, but also how we can potentially improve those controls. And we'll talk a lot about that today in this webinar. We also get involved in looking at accident causation, and quite often that's looking at large bodies of data or try to understand the precursors that might still exist in organisations well beyond a serious incident occurring. And we do a lot of work in that controls assessment space, which again we'll uncover a bit more today as well. So in terms of what we're going to cover, there's obviously the white paper, which underpins a lot of the conversation today. We'll talk about control classification, and how we've used our scale control health assessment to kind of unveil some of the areas of unreliability, if you like, or inadequacy in terms of control frameworks that we've seen through our analysis and the work we do. We'll touch on the research findings, and Warren will expand on the variability of humans in the work that we've analysed, and also give you some approaches in terms of how you can improve controls. For those of you who aren't familiar with the work we've done, just a quick recap in terms of our research. Our founding research was done with Federation Uni, and what we did was we built on this research through the analysis of very large bodies of incident data across around about 12 countries, 12 industry sectors, so ranging from utilities to mining sectors to transport, etc. And so you can see on the visual there, it's quite an expansive study, and we're still building on that as we speak. In terms of the data that we've drawn on for this work, but in the work that Warren's going to talk to today, but also the white paper, we've analysed a body of around 10,000 incidents, of which we did a deep dive in around 680 of those, where we felt there was more reliable data on which we can actually deep dive and extract a lot of value out of. And so those 680 incidents that we did a deep dive on unveiled around, in excess of 1,000 controls that we felt were really opportunistic for a more expansive study, which is what we're going to talk to today. There were about 6 takeaways from the meta study. We've started to unpack really findings 1 and 2. And so the first webinar in the white paper that accompanied that was really around the notion that organisations don't really have reliable data through which they can better understand and learn from serious incidents. And that's really due to misclassification. We've then started expanding on, of those incidents that occurred, a lot of the controls that were either absent or ineffective were largely due to human reliability. And so the previous webinar and this webinar is really trying to unpack that with a bit more substance, and we'll talk to that in a bit more detail now. And there's 3 or 4 other key takeaways, which I won't dwell on right now, but there's very much learnings around better understanding human error and how we can better design work to be more resilient to accommodate that natural human variation. We'll talk more about the operations that are local to those incidents that have occurred, the upstream organizational factors. And of course, a lot of the data can get quite technical. And so we're going to park a fair amount of time to unpack the motor vehicle and gravity-related incidents in a bit more detail as well. But let's jump into it. So I think most of you are probably very, very familiar with how we assess controls and how we try to reduce exposure to the workers through various frameworks. And I think, Anthony, in your work, you might have seen and been exposed to a whole bunch of different frameworks. Obviously, there's the ICMM guidelines that leverage different tools. The new is it called QG35 has also got some frameworks in there. What are you seeing?
Yeah, thanks, Alex. Yeah, I think I've seen all of those different control frameworks and more. I think that they all have their sort of purpose, I guess, or strengths and weaknesses. I mean, one thing I'd say is like most companies, apply at least one or more of them in some form. They're not all applied in isolation. Some things that I would notice about them though is a lot of the times they have quite large groupings. Like, so for example, the hierarchy of controls, we can talk about that. Is goes from an engineering control to an admin control. So there's always a lot of debate about that, right? Moving from an act control to an object control. They're quite large groupings, and there's debate about where things sit. So that's one thing I would observe about them. So I'm interested to hear more about Warren's the approach you guys have built around control classification, and to get a little bit more granular. Another thing I'd say about a lot of these is all of them, apart from one, I think, which is the one around function, prevention, detection, correct, and recovery. That one talks about where the control sits in the sequence, which I think is really interesting. And I know the model you guys have builds upon that. All of the others focus more on what type of control it is. Is it a more of an object engineering harder control, or is it a softer, more human dependent admin control? But what I've found is even in companies that use one of these approaches a lot, they don't always necessarily do anything more or different in terms of their system. So once something is defined as an engineering control versus an admin control, if I use that most common example, it doesn't necessarily lead to a difference in how the control is verified in the field in practice, for example.
Yeah, okay.
Or how a control is how investigations may treat those controls differently, etc. So it's kind of a bit of a one and done. Often it doesn't get sort of operationalized through the system. So I guess that's probably some of my observations there, Alex. So keen to explore, understand a bit more, the model that you guys have developed.
Yeah, sure. What are your thoughts?
Yeah, it's probably important for us to sort of paint scene a bit here. When we looked at those 680 SIP potential incidents, we were obviously looking at the controls that were absent or ineffective. We made a judgment call about, and which we talked about in the last webinar, about whether those controls would have been easy or should have been easy to implement versus maybe not so easy, a little bit tricky in the context, the physical context of the task. But I think, when we performed that analysis, the question about relating to what Anthony's just talked about, it really emerged very quickly for us, which is, well, okay, there's 1,000 controls here. So why do some tend to fail more frequently than others? Why do some seem to be, more vulnerable, to being ineffectively implemented, in the field, regardless of whether they're easy or difficult? And I think that's when we started looking at basic things like hierarchy of control, and we asked ourselves the question, well, surely we could just sort of take something that's already well known, well established. And as we started looking through each of these lenses that Anthony's just talked through, none of them really kind of stood out to us as covering enough of all the bases that we were looking to understand, because we obviously want to understand, how do controls work, but what's their purpose as well? Or what are we actually trying to do with them? And Anthony very artfully described a couple of distinctions here. I mean, the functional option is important, but we also want to talk about the design of controls. So hierarchy controls was my first port of call, because I thought, look, everybody knows hierarchy controls.
Yeah, sure.
It's and if we bring up just the graphic that sits on the right hand side, I looked at just a generic set of controls that would sit under vehicle collision. Some of these people would argue, well, some of them really aren't controls, but these actually came from organizations that we've worked with, so they're not necessarily things that I've constructed. But when I looked at them through the lens of hierarchy controls, really I only had two distinctions. They're either administrative or they're engineering. And when I pick up there's six here that I've highlighted, Alex. Those three engineering controls are different to the three blue engineering controls in one very important sense. Is one group of three are still very, very behaviourally dependent, and the other three are probably somewhat more independent of human behaviour, in the sense that they work by themselves. And so it became really clear to me then that, particularly when we started looking at the frequency of these control failures and what types of controls tend to fail more frequently, we needed something that was far more fine-grained, finely tuned, to those two parameters, which is how do controls work and what's their purpose. So design and purpose were the two lenses we want to look through, and we'll get into what the model looks like in a tick. But I think there's a poll coming up, Alex, that we probably would like to get people's opinions on.
Yeah, absolutely. I think clearly there's a diversity of control frameworks and classifications and tools that are used out there in industry, and no doubt they've got pros and cons to Anthony's point. But I think there's also some nuances, as what you're suggesting was that some of these frameworks don't necessarily help you improve the control because of the way the controls have been designed.
That's right. I mean, look, the objective here is, if I've got something that's frequently failing, I need to understand why. But if it looks like it's manifestly inadequate, well, what would a stronger control situation actually look like? And we need a sort of a graduated scale that helps us to guide what that improvement should look like.
Sure. Well, let's throw to people who are on the webinar as well. I think it'd be useful just to maybe for the conversation to just help us understand what have you seen that's been used? What's the predominant method that you've used in your organisation to assess controls, their integrity, their reliability, their design. So clearly, everyone's probably familiar with hierarchical controls. I'd be very surprised if they haven't. There's the notion of active versus passive, so engineered hard versus soft controls. CCM, so this is critical control management in general. There's obviously variants on this, but there's critical, non-critical, supporting and verification controls. There's certainly the functional perspective, which I think Anthony just talked to as well. There's a high energy one, which is probably, is that the Hecker one, Warren? Is that the one?
Yes. Yeah.
Okay.
I should have probably put Hecker.
So that's obviously a contemporary approach to assessing controls in the field, which has actually got some utility. And then there's obviously pretty well-known barriers and safeguards, which is probably more an oil and gas kind of lens. But look, there may be one or all of those that you might be seeing. And I think if Nina can put the poll up, that'd be fantastic. Hopefully everyone's got access to that poll. And if you could respond with what you've seen being used, and if you've got others that you've seen, please drop it into the chat as well. I'm assuming the poll is up and running. What have you seen, Anthony, in terms of the predominant use of control frameworks?
Here's the poll.
Okay.
I mean, obviously, hierarchy of control is the most, prevalent, but also the most discussed, right? If you want to wreck a dinner conversation amongst the safety people. You don't talk about politics, religion, or hierarchy of controls.
Yeah,
It's
right. There you go.
keep them going all night. So that's obviously prevalent. But I mean, obviously the critical control work is pretty predominant too, right? But because they're different constructs, you may go through the control selection or design process thinking through the hierarchy of controls, and then when you get to the end of that, you then may be considering which of the resulting controls are critical. So I think that's probably a point. So that each of these methods is not necessarily restrictive of the other.
Yeah, absolutely. So let's end that poll there. And for those of you who've just joined, I can see a few more have just joined the webinar. We're just running a poll at the moment to just elicit what you have been exposed to in your experience, either in the current organisation or others, where you've used a particular methodology to understand the reliability or the integrity of your controls. And there's a lot that have been used. So let's stop. Okay, so the poll's done. So it looks like we've had a few responses there, and it's very much the hierarchy of controls seems to be the predominant one that people have used. There's also a couple of chats, so I can't see the chat, unfortunately. Have we got anyone else that's added to the chat? All good. We can keep moving.
Maybe some people had some trouble getting the poll to work for themselves. Because I think only 2 people have responded.
Okay, there you go. So all good. But look, feel free to throw a question into the chat or to into the Q&A, preferably, if it wasn't working for you. Okay.
Let's talk about our framework.
Yeah.
What do we come up with? And as I said before, Alex, we were looking at the design of controls, but also what are controls actually supposed to do in them? Where do they sit in the sequence or in the action sequence? And obviously, that very simple equation around prevention, mitigation, and response. We call it response. There's probably other words for it, but we've got a simplified version of it here because there's only so much you can fit on a slide, and we want to make it readable. But there is a bit more to this framework than what you're seeing. But I have this simplified version sort of cuts it down in terms of the number of distinctions. But fundamentally, we're talking about hazards or energies that and we can deal with the existence of the energy in the first place. We can help manage the release of that energy. We can create separation, obviously, between let's say moving objects and people. We can provide protection when we know that the damage, potential damage or impact is actually likely. We can provide protection in that circumstance, and we can obviously also minimise the impact of the event as well. And all of the controls that we've put into any of these categories, they'll be quite different in the way they're designed as well. So let's have a look at the design features, Alex. In the first instance, we felt that when we noticed these, unfortunately not frequently enough in organisations where they're physical controls that really don't have any kind of relationship to behaviour per se. They are fixed controls. They do their job independent of a human. I mean, sure, a human probably has to at some point maintain or inspect, verify that that it's actually working, that it's structured properly. Imagine a wall that separates forklifts and pedestrians, as an example. At some point, there's probably going to be the odd bit of damage, and you'll have to maintain it. But fundamentally, it should work, very consistently. Exposure trigger controls, very similar. Exposure trigger controls tend to have a little bit more vulnerability to mechanical failure. An example there, like a vehicle airbag, you'd expect that to work, but they don't work forever. In fact, airbags are known to actually fail under sort of certain conditions, particularly later in life. Interlocks, light curtains, those things, they're quite active controls, but they should work without the human having to trigger anything. They trigger themselves based on the exposure being activating to a certain level. Behavioural controls are a bit different, obviously, and we make two distinctions here where we say, look, you've got the hardcore procedural sort of, completely human behaviourally dependent controls, like stand over there outside the line of fire. Can we actually be outside this 3 metre exclusion zone, please? It requires, for instance, Alex, you and I to have exactly the same idea about what that 3 metres looks like. And of course, this is where we see a lot of, variability happen that causes people to actually get those situations wrong. Technical controls are actually similar in the sense that you've got a person needing to do something, but they're doing something with a piece of technical equipment usually. So a classic example there would be, I'm standing outside a confined space entry with my atmosphere monitoring device. And I've got to have it calibrated. I've got to make sure it's working. I've got to know how to read it. I've got to know where the limits are. At which point I'm actually going to say, whoa, stop, we've got a problem here. So the technical control is a little bit more, it requires more knowledge. It certainly requires a certain sequence of actions usually, but it's still behavioural. So they're the 4 types of designs. And we know that the reliability of each of these 4 categories are quite different. We would expect greater unreliability on the far right-hand side of this, and much greater reliability on the left-hand side. Where do most controls sit? In any control architecture that we've seen in the organisations we partner up with to do our research, on the right-hand side, of course.
Right.
And in fact, it's not that. What I've noticed is that not organisations don't ignore the fact that they've got exposure triggered and permanent controls. They just don't actually have them listed as needing to be verified. But what we do know is that in most the controls that are described by organisations as needing to be in place and mandated, to be implemented, they are predominantly technical and behavioural.
Yeah, right. And so I mean, when I looked at this framework originally, Warren, I looked at it as being, it's almost like the purpose of the control as imagined on the vertical axis, and obviously it kind of aligns to the bow tie to a large degree, prevention, mitigation, response, but then the design aspect for me is almost how reliable is that in practice?
Yeah,
is that how you kind of look at it, Anthony?
Yeah, exactly. And I'm just thinking through like some of those other control frameworks that people may be familiar with, like the direct controls versus alternate controls model. Clearly the direct controls are going to be more, the various shades of green, and the alternate controls are going to be, more in the behavioural side. And the same with the other model, that the barriers versus safeguards. Well, barriers are going to be in the green zones, and the safeguards are going to be on the right hand side. But I think what I like about the model is the extra granularity to say, not just that, but where is the control being called upon in the accident sequence. So it's really quite helpful when you get into looking at the concepts around, well, therefore, which of these controls should be critical controls, and so forth versus others. I noted there was a comment in the chat, Warren, around, well, what do the colours actually mean, and the scoring system. But I guess to that point, we're ultimately trying to drive towards A1 controls.
Yeah,
but we need to recognise that in most contexts, in different contexts, different controls are going to be needed. But yeah, do you want to maybe just describe what the
how the
matrix works?
They're obviously, yes, absolutely. That's what we talk about, layers of protection. To manage a risk. Because typically one control in a solo sense is not going to be enough. To manage a risk comprehensively. So we tend to see layers of controls. And the number of permanent controls are usually very, very low in number because they actually usually cost quite a bit to implement. And similar with exposure trigger controls, although with technology coming on, improving at such an incredibly rapid rate at the moment. We're seeing far more exposure triggered control opportunities to be implemented. The reason why the colours are the way they are is that whilst we would fundamentally say, look, you actually need prevention and mitigation and response controls, and they're all important. When down that left-hand side, we would say that it's probably better for us, conceptually and intuitively, to try to prevent an energy from even existing or from getting out of control or from releasing than just focusing on mitigation. So if I had a choice, I would probably prefer to try and prevent in the first place. Now, that's actually difficult to guarantee 100%, obviously in any high risk or critical risk task. So that's what we do need mitigation controls, because we can't ever really be absolutely sure that we have got our exposure down to zero. In fact, that's actually quite unlikely. So on the right-hand side, same thing, obviously, providing protection is important, but providing protection would be less necessary if we actually do a really good job in terms of prevention and mitigation. So that's hence the colours. And obviously we tend to focus on the right-hand side being less desirable, mainly because it's far more likely to be less reliable as a control than on the left-hand side. So they're the distinctions. Sorry, Alex, you were...
No, all good. Look, I was just about to extend on that in that it's not necessarily only being in the top left-hand corner, because of course you do want people, you do want to be able to fail safely. So having the appropriate mix is also pretty important. There was a couple of other questions coming through, and so this is great. Keep the questions floating through, because I think rather than wait until the end, we might as well just have this as a dialogue. So question or a comment: to get to higher level controls requires business support and a business case submission. This takes time. People want quick fixes, and there's also a drive to close incidents and investigations.
I think that's a good segue to one of the next slides, Alex. Around the...
Ian's just asked a great question too, Ian Brown, and welcome aboard, Ian. Talking about perhaps leveraging this kind of concept around distinctions between controls and feeding it into your prioritization and verification strategy. So where would you focus more of your effort on verification? Well, probably where there's actually greater chance of unreliable or inconsistent application of those controls. And we know that behavioural and technical controls are far more likely to fail. So absolutely, great question, Ian. Thank you. So this is just a worked example, by the way. We thought keep it simple and something that's familiar to all of us. Driving a vehicle. We've back in the day when I first started driving, not all the service stations actually had pressure gauges, on their air pumps. You just had to basically guess that you had the right kind of air in the tyre. You kick it a bit, or look at it from the side angle and try and make a judgment on, how flat was it. And obviously a technical control far more useful. I've actually now got to read a gauge. In fact, I've got that gauge to guide me on whether or not I even need to put air in the tyre at all. If I'm a bit suspicious that it's deflated. An exposure triggered version of that would be something that some people would have familiarity with now, in their cars on the dashboard. You'll be able to see an alert that a tyre actually has started to deflate without you even having to look at the car from the outside. And in some cases, it even gives you the actual pressure. If you have a Bluetooth adapter on your valve, it can actually signal even down to sort of half a pound loss, in that tyre. Even better still, of course, you could have an automatic inflation device attached to that, which because this exposure trigger control still requires a person to make a decision to do something. A permanent control on the right-hand side, though, of course, and people may not have realised that, in fact, there's new tyre technology being developed all the time, and this is one of the more radical ones where there's no air at all in the tyre. So we've kind of eliminated that risk in some respects. So each of those four examples have quite different levels of reliability, accuracy, and likely effectiveness in the real world.
And look, I think the other piece to the comment before about the business case. I mean, often if you're not building the data to kind of inform how you then shift exposure towards permanent or exposure triggered. You can't necessarily build a business case and have leaders advocate for a change, right?
Absolutely. Yeah.
Yeah, 100%, Alex. And can I just add, back to that, I guess my comment at the start about the size of the buckets on the hierarchy of control. I mean, I've definitely been in organizations where they've set targets, right? We've got to have X number of our controls as being engineering controls. And the safety department goes, wow, well, we're mainly relying on procedures, so we need to get to engineering. It's kind of like a big jump. As soon as I see that control matrix you guys have developed, that's more granular, but not too granular. I think it's kind of right size. I could imagine a safety department or whoever then working out how they can move up that ladder in a more stepped manner, as described down the bottom here. I really like this example, and as you said, generating data then is the next step to be able to support moving up the model and the business case to do so.
Excellent. Well, let's have a look at the data from our study itself. I mean, we've analysed the 680 incidents and identified a whole bunch of failed controls, absent or ineffective controls, and a large proportion of these controls failed due to unfortunately, the expectation that someone's going to do something at the right time, in the right order, in the right sequence, and be alert for work, in the manner that we kind of imagined they could. But of course, we all know that we're all susceptible to fast brain moments. You forget driving to work, how you got there sometimes, because it's such a repetitive, autonomous task that it's actually easy to kind of lose track of what you're doing. And so we're really talking about, and particularly in the last webinar, we talked about enabling people and setting up systems so that people are set up for success. But of course, what this data has kind of highlighted is that a lot of these incidents are breaking down due to human error, as it were, memory, attention, skill, decision making, etc. So, can you expand on this a bit further for us?
Yeah, sure. Thanks, Alex. The controls that we've put into the the pure procedural bucket. I mean, you're right. It's more. I mean, sometimes people work outside the boundaries of the mandated kind of requirement, sure, and they make a decision to do that. We discussed that in the last webinar a fair bit. People somehow feel that the situation's not perfectly set up for them, to be able to implement the control or perform the task in exactly the right way, and they make a decision that's the wrong decision. Their judgment of risk is probably not exactly spot on, but a lot of it's actually about slips, lapses, and mistakes, where they're actually intending to do it the right way, and do it in a where risk is as low as reasonably practical, and just somehow it turns out wrong. And it could be a misstep in a process. It could be just simply an error of judgment, around assessing the risk. Whereas the technical ones, probably there's a fair element of that, of course. We see a lot more mistakes with technical, because we're asking somebody to use a piece of technical equipment usually. So experience, knowledge, and skill comes into the mix a little bit more, but also the reliability of that piece of equipment that's got to be used is an issue. So about 30 to 40% of those behavioural, the technical controls that have failed were down to a problem with the piece of equipment, that the worker may not have necessarily have been able to judge correctly or understand before they started using it, would have expected it to be 100% and it wasn't. So they are the reason for distinguishing these two types of controls is important, because there are different failure modes that tend to drive them to fail. Some of those examples on the right-hand side there around the pure behavioural, procedural controls, they're fairly obvious, and really I'm not really being asked anything particularly technical to do there. On the left-hand side, though, we suddenly start to see some things that require skill, awareness, knowledge, technical skill, particularly where I've got to know how a thing needs to be done, in far more detail. For instance, an erection of a temporary barrier. Well, I've got to actually have some specifications for what that needs to look like, rather than just stand over there outside, the line of fire. Applying a neutralizing substance to skin. Well, when is it appropriate? Am I going to be allergic to it? Suddenly, we're starting to ask a lot more questions about how and when that control needs to be deployed, and where. So they are a little bit different. What we did find, was that the 4% of physical controls, which is a very small percentage, it was about 40 out of 1,000 or so. They were mostly about exposure-triggered controls that hadn't been maintained properly and just ceased to work. Like IVMS, for instance, in a vehicle that simply wasn't working, hadn't been checked, for the last. Like a monitoring device inside the back of a truck that's supposed to sort of indicate that a load has started to shift, and no message inside the cab of the truck that that's happened. So we find that you still need to be wary of physical controls, and not be complacent about them, because sometimes they do go astray by themselves if they're not maintained. But mostly it's about skill, attention, memory. We're talking about all of those classic things where humans just can't be expected to perform perfectly every time the task is done.
Yeah, and look, I mean, it's interesting because we use the word behavior here, which is probably it probably incites a bit of concern, a bit of a Voldemort kind of statement. But really, what we're trying to do is acknowledge that there is a human in the loop of enacting these controls, and we're all susceptible to some level of error depending on context, circumstance, just the way we're wired, right?
Yeah. So there are a couple of the point of all of this, of course, is that there are some tasks we are not going to be able to remove all of the potential effects of human error and the likelihood of human error. So we should seek, though, of course, to try to allow people to fail safely as much as possible by putting either mitigation or other preventative controls that actually kind of compensate for that as much as possible. When we can't ignore the fact that there are certain conditions that tend to produce a greater intensity of error likelihood amongst people, and I think the next slide does capture that pretty well. If you put somebody, for instance, in a complex task situation and they've got relatively little experience, and this is a very obvious example that everybody would probably be nodding vigorously to, or you're staring down the barrel at a very high error rate likelihood. So a totally unfamiliar task performed at speed, no idea of likely consequences, you're going to have a really an even chance, a 50-50 chance of a problem. And this is research that's come out of the heart analysis method. It's a human error reduction set of concepts that were developed back in mid-80s, I think, by J.C. Williams. And since then, there's been a lot of research done to sort of validate it, to look at it in real world situations, and take those task contexts and see, well, what is our actual real likelihood of error? And you can see here, it gets down to very, very small error rates, in some situations, completely familiar, well-designed, highly practiced routine task. Yeah. You'd expect it to be pretty much almost error-free. But there are several here. When you have a look at all of the high-risk tasks that you want people to perform to implement a behavioural control, and you ask yourself the question, where do most of those tasks fit? They don't sit at the bottom end of this. They tend to sit in the middle, in that GTT 3 and 4 and 5, and that's where your error rates actually are quite a bit higher, your likely error rates. And then you've got error-producing conditions, which of course tend to be a multiplying factor. When the minute you start putting a time restriction on a task, or create any kind of urgency, if you are expecting people to judge risk in exactly the same way, they won't. Operator inexperience, is a really, really significant factor in terms of multiplying.
So on that, I mean, this is obviously pretty well-founded research. That's obviously, we've leveraged that in the way we integrate this into our analysis using the scale method. But Anthony, in terms of the work you do, like you obviously do a bunch of, a lot of bow tie analysis, a lot of critical control kind of analysis. Do you see organizations focusing on these aspects of their control architecture at all? Like, how would they consider this
I think
typically?
I think it's probably fair to say, Alex, generally in industry only in a fairly superficial way, like we said before, around differentiating between, procedures and harder controls, and then of the procedures, what's the nature of them and so forth. Like, clearly in more sophisticated oil and gas and organizations and so forth, they get more involved into the assessment of those procedures in terms of its, error tolerance and so forth. But I'd say generally in industry, we're at a fairly lower base than that.
Yeah, okay. Interesting.
And Alex, it's not to say that, obviously all errors do not result in incidents. We, as humans, it might only be 1 in 100 of our errors, unfortunately, turn quite ugly. We get away with it most of the time. That's when you go out in the field and you perform verifications of high risk work, and you see things that aren't quite sort of conforming perfectly. They are going to be, they'll still get the work done. It's just in a way that we're not quite, interested in seeing. But the problem, of course, is that it's when is that error going to produce an incident, and we don't know which one it's going to be. This is just a worked example of vehicle incident controls. We thought we'd just take a set of vehicle controls and see where they sit in that sort of prevention mitigation response, but also what, in terms of their design, where do they sit? And also what's their failure with our 1,007 or so controls that we've analysed. How many of those control failures sit within each of these categories? And I'll show you that in a second. But just to sort of work through this, you can see this set of controls here ranging from permanent ones all the way down to our pure procedural ones. And I think if you have a quick look through the list here, you can see how they relate to exposure triggered, technical, procedural. There usually aren't very many permanent controls. So I only had 3 to choose from. Interesting, pedestrian vehicle segregation does actually fail occasionally, even when they're hard barriers.
Right.
On the mitigation front, I just had 4 there that I put into the mitigation area, which were all exposure triggered. You'd expect to see, you certainly expect to see airbags, seatbelts, and vehicle crumple zones these days. You don't always see collision avoidance systems, in vehicles, particularly corporate, like company vehicles.
Fleet, yeah.
And on the right-hand side, we've got our response where you would expect to see, a lot of these things actually, kind of in place for organisations that have large vehicle fleets in high-risk situations. Like in the mining sector, obviously, we expect to see quite a few of these controls listed. They often, I've got to say, our research, the response controls are likely to be the least reliable of all of your controls. They don't get verified. Drills don't happen. And if we don't pick up the fact that we didn't do a drill, around emergency response for the last 3 years when we're supposed to have done it, and then when it is required, we suddenly find the alarm system or the smoke detection system isn't working properly. People don't know where to go, so I would just caution people that that's an area that's often just ignored when we do our verification of controls. But the key issue here is that we've got a whole raft of, and there's a few support controls which are obviously very important that sit upstream that set us up, for the more acute, kind of hazard management, in this prevention column. When we look at the frequency of failure, though, check this out, because yes, of course, a lot of those support controls, some people say they're not really controls, they're support activities. A lot of those are very, very much in the mix when it comes to analysing why did the incident occur. But the main volume of control failures is going to be in this bottom area of smooth steering, brake, accelerate, scanning for potential hazards, maintaining safe distance. All of those really tricky ones that the organisation is going to find very, very hard to reinforce and control. And it comes down to skill, attention. It comes down to a driver's willingness to sort of really hone in on the risks sitting in front of them, and to remove any sense of complacency. Very hard for all of us, because it's such a familiar task, driving
Yeah,
a vehicle.
absolutely.
We're not actually trained to be fully attentive. It's not something we like to do because we do so much of it. And this is the trouble with any routine task that we've done over and over again, is that it's very, very hard, much harder for us to switch on that focus and attention. So the question would be, in this case, what would I do about that? If I know I have such a high failure mode happening in one particular area, I need to think about helping to compensate for that by inserting some exposure trigger controls, which help us to fail more safely, not completely safely, but to fail more safely than we can, today, just as humans, in control of the,
Yeah,
of the vehicle.
absolutely.
And that's where the vehicle detection with inhibition, and that's inhibiting, speed and etc. Speed and the throttle, vehicle speed limiters and geofencing. Coming into an area where I'm required to be at 40k an hour, and actually having the vehicle do the job for me without me having to actually consciously slow down. How many times have we been through a town and not even remember we've been through the town on a long drive? IVMS interlocked, descent control systems, collision avoidance systems. These are all really, really useful technology. You don't always see it in fleets.
And look, clearly, in the absence of a business case to invest in those kinds of technologies, I mean, there's things you can do around, amplifying maintenance or supervision, or even verifications more honed into those more susceptible controls. Would be fair to say, Anthony?
Yeah, absolutely. I think that the two things that this also highlights, in addition to being able to clearly lay out your control strategy, is the point you said about once they're part of your control strategy, they all need to be verified in some form. Not, we shouldn't let the emergency ones on the bottom right-hand corner slip off our program. And then the other point made earlier around, focusing in on those more vulnerable controls around better ways to verify and at what frequency.
So maybe some other examples then, in terms of how you can shift the choice of controls to the top left, is it, as it were, Warren? Maybe just pick on a couple of these would be very useful.
Well, the point is, let's not work through all of these, because I think people can read them, and they're fairly obvious opportunities. But I think the key point here is that it's difficult without good, reliable data around control failure, and actually understanding the distinctions between the controls that tend to fail most frequently. In other words, why are they failing? Difficult to make your case to shift to these physical controls that obviously are, sometimes they're technologically challenging, sometimes they're financially challenging, but inevitably, with the rapid acceleration of technology at the moment, I don't know that there's actually too many behavioural controls that won't be able to be compensated for by
absolutely.
some really useful technology. And these are some great examples. You won't always see these in organisations, even when they should be in place. A lot of organisations have been sort of fairly slow to pick up on those opportunities. But
and look, I mean, when I looked at a data set, which is at the subsequent slide here, what occurred to me was that it's almost like I don't know what I don't know. Like you could have had, use those control frameworks and taxonomies and tools that we talked about at the start of this conversation. But then when you reassess the controls as they exist, and you get a better sense of how reliable or lack thereof that actually is, it gives you a sense of, well, now I actually know how vulnerable these controls are, and I can start doing something about it, or at least start advocating for a shift or a change of focus. Anything for you, Anthony, that kind of strikes you with this data set?
One thing about this data set that I'd like to ask Warren, and it's probably a question that people on the webinar have, is this data comes through control failures relating to incidents. So obviously, does that or does that not skew the reliability of controls. If we were to look at control verification data, would we get a similar pattern?
Yeah, good question.
Great question. And fortunately for us, Anthony and Alex, we've been doing a bit more work around lining up control verification data outputs with incident data from the same organisations. We didn't do it early on in the piece, but we've been doing it. The last few projects or research projects we've been involved in, we're starting to see a very, very solid overlap between the two. Which is great, because what it says is that organisations are actually doing a pretty good job of their control verification in terms of the quality of it. Like, it does line up as you would expect it to. If there's an incident happening, we'd expect to see some control failures that didn't turn into incidents that are good weak signals to the eventual incident that's going to happen. And we are seeing that overlap. It's not 100% by all means. And look, there are controls in organizations' control architecture where we see exposure triggered and permanent controls shown, and they don't fail very often. But my sense is that this is actually fairly reflective of most control frameworks, what we're seeing here. Certainly in terms of the types of controls that sit in certain categories, falling object and work at height, for instance, are quite different in their profile. And the kinds of solutions that you would have to try to improve the robustness of those controls, they're quite different. And one is certainly about trying to more focused on prevention. The other one more focused on mitigation as well.
So I think for our viewers here, there's probably a few takeaways, and I think clearly we're drinking from the fire hose as well, because there's a lot that we're kind of challenging in terms of the way we look at your traditional control frameworks. And we're not suggesting that you do away with one and switch to another, but I think it's about taking the opportunity to look at how rigorous is your existing control system as it's implemented. And so my invitation to you would be to consider using a control health assessment framework, and you've got the tools there as they are in that kind of simplified version. But of course, the key takeaways for us are really around, consider redesigning controls that frequently fail, or even just be more aware of the ones that are more susceptible to human error. I think one of the audience members talked about considering modifying your verification program so that you're more focused on those susceptible controls. I think using the investigations process is pretty key. So we obviously use the SCALE methodology, which is a controls-based methodology. And you could adapt your existing methodology or even leverage ours, but certainly use your investigations with a controls view. I think to Anthony's point earlier on, quite often you've got this control architecture sitting here. Leverage that when you look at your investigations, and clearly, looking at systemic factors. So I think Warren talked about IVMS, which is kind of further upstream outside of the control of the person driving the car. There are several systems that support our controls and the effectiveness of those controls, and so focusing on those and saying, well, how do we shift the dial on those to set up workers for success in implementing controls, and quality verifications, which we talked to as well. Anthony, any parting kind of insights or comments from your end?
Well, it's been a really, really good webinar, Alex and Warren. I always learn a lot. So one of the things for me, I think Warren may have written in his white paper something along the lines of not all controls are created equal. I really like that statement. It's kind of obvious, but I think this gives a method to being able to understand the strength of those controls in terms of where they sit in the framework, and it make it granular enough to make it realistic for people to be able to move controls up the framework to become more reliable. Yeah,
good. And look, no doubt a few of you have probably got some more questions, so I'd encourage you as we shift into Q&A mode, just feel free to stress test the approach, or you might have some other burning questions that you'd like to ask. While you're doing that, I'll just draw attention to, look, if you'd like a complimentary review of your framework, feel free to reach out. More than happy to overlay our approach on your existing framework. And so there's a QR code, there's a link that you can hit, or you've got access to our contact details as well.
And Alex, even if you just want to have a chat about some more of the research and how what implications it could have, for the work you're doing in your own organisation, we love to talk and help people, even just think, kind of get the chance to actually think and consider these issues, which often in the day-to-day is difficult to do because you're usually fighting fires in safety, unfortunately.
Yeah, absolutely. And I've got a couple of questions coming through, but if you've got some more, feel free to throw them in. And then, of course, if you want to leverage the scale methodology, feel free to click the links and QR codes and things like that, and leverage that as a different approach. That one that's actually complementary to your existing approach, I would argue, but certainly takes a different lens to serious incident analysis. So, question I've got here. So, when you're looking at incident data, was there a commentary about redesigning the work and not just the controls? Yeah, great question, Ian.
Yeah.
Can I throw that to you, Warren?
Yeah, absolutely, Alex, and thanks, Ian. With the one of the first things to do here is to try and understand if it's a purely procedural control, that tends to sort of repeat itself over. The failure repeats itself over and over again. One of the first things to do is to understand, is there a way for me to redesign how this task is performed, to take out some of the complexity? If you can understand the failure mode, is it a memory issue? Is it a getting sequences out of or getting steps out of sequence? Is it a like the performance criteria just never being met? For that, which means that we actually haven't been specific or articulate enough around that performance criteria. We should look at that first. Because sometimes that can actually change, tweak the dial quite significantly on reliability. But then, though, if we really exhausted all those possibilities, I think that's when we probably got a good business case, to seriously redesign the control itself.
Absolutely. Look, I think there's a couple other questions. So if you've got time for one more, maybe. The concept of an illusion of protection leads to procedural drift. Any thoughts on that? That thought, on that comment, Warren?
And I'm going to throw that one to Anthony.
So the concept of an illusion of protection leads to procedural drift.
Yeah, maybe not the procedural drift bit, but I think definitely when we have harder controls, even, or some of the technical controls, there's also an illusion of perception that they're set and forget. When Warren mentioned earlier, the importance around maintenance strategies and other things to prevent the erosion of those controls, I think is a really key point.
Yeah, we don't even see them in verification programs half the time.
Yeah,
like they just don't even get on the checklist at all.
Yeah, that's right. And a lot of those really important controls are actually not even visible. Whereas a lot of the health and safety controls are very observable and visible. So, they can drift over time in terms of their effectiveness.
Yeah, good. Another question. I'll close this off as the last question, but while engineer controls are often considered higher in the hierarchy of controls, you state that lower level controls are of equal importance. Can you discuss why a combination of controls and layers of defense are essential?
Well, I'll give you an example, Alex. If I'm out in the field as a remote worker and I've got exposures to, kind of nasty little animals and critters and insects and snakes and whatever have you, one important control is that I actually have the knowledge and skill and training, to understand how to manage myself, and also that I can actually identify very, very quickly any hazards or risks, when I'm actually out in that sort of solo environment. I actually do need PPE as well, though. So PPE is a low down on the hierarchy controls, but give me some gaiters, please, if I'm going through long grass, because I just need to be, I want that protection. Yeah.
Absolutely. Well, look, let's bring it to a close. I appreciate everyone, and particularly Anthony, your time and contribution to the conversation. I think it always adds a lot more real world context for us. And I appreciate your time on this, Warren. And thank you everyone for dialing in. The recording will be available post the session today, and feel free to jump on that or circulate that to your colleagues and peers.
Thanks,
Have a great
Alex.
one.
Thanks, Anthony.
Take
Thanks,
care.
Nina.
Thanks all.